Ok- Okay, guys, this is just a review of what we did the other day, and we're gonna just give you some hints so you guys can finish this IXL today. So I asked you guys to watch a video and then to do the IXL assignment. So if you're good with how to do this, go ahead and start the assignment. And if you get stuck, you guys can come back and watch this video. Okay, we're solving a system of equations. As you can see, there are two problems, 1 and 2. And we're going to try mixing those together. And we're going to use substitution like they asked us to here. That means we're going to take one value and plug it into the other. And as you can see, x is by itself. And we're going to go ahead and plug that into this x here. So on a separate sheet of paper, you should be writing this down. We're going to go ahead and say negative 2. X is now negative 5, right? Plus 3y equals negative 20. And as you can see, we only have one variable left, making this an easier problem. Instead of starting with two variables, like we did over here, we substituted our x in as negative 5. And now we only have one variable left. Let's go ahead and solve it. Negative 2 times negative 5 is positive 10, plus 3y equals to negative 20. Hey, great. Now we just have to solve for y. Let's get this done. What's farthest away is 10, so we get rid of 10 by subtracting 10, opposite operations. 3y is equal to negative 30, divide by 3, divide by 3, y is negative 10. All right, now if we know y is negative 10, well, what's x going to be? That's, plug it in. Wait, we already have what x is, right here. X is negative 5. That's it, and that's our point. If you want to double check, we can plug x and y into our original equation. Let's go ahead and do that. Rewrite it as negative 2x plus 3y. Does this equal to negative 20? X we said was negative 5. Y we said was negative 10. So 10 plus, wait, that's a positive times negative is negative 30. Does that equal to negative 20? Yes, it does. Negative 20 equals to negative 20. Okay, next problem. Okay, in this version, you see that they're both y. So we, in our example from the previous day, we set them equal to each other. Y is equal to negative x minus 4. Y is equal to negative x minus 4. Y is equal to negative x minus 4. Well, if y equals negative x minus 4, well, this y here is equal to negative x minus 4. And we're going to copy down the right side. See, that just goes right here. And we're going to combine like terms. I see x and x. We want x to be on the same side. So I have more x's on my right side. See, more x's here. Because it's a positive. Negative 4 is equal to 2x plus 10. Now it's a two-step equation. We mentioned that we were solving for the variable x. So let's get x alone. See, okay, x alone. Let's get rid of the 10. We're going to minus 10 to both sides. Minus 10 to both sides. Negative 14 is equal to 2x. Divide by 2, divide by 2. X equals to negative 7. Now in this problem here, we only have x. We have to look for y. But we have two equations here that would give us that possibility. You can either plug it up here as negative 7, or you can plug it down here as negative 7. It's really up to you. I'm going to go ahead and demonstrate, like we did before in class, that it doesn't matter. They're both going to give us the same answer. So let's do the first one. Y is equal to negative minus 4, and x is going to be negative 7. Negative is a positive 7 minus 4, and that leaves y is equal to be 3. Well, let's try the other one. Would this have worked on the other side? That's on the other side. Y is equal to blank plus 10. And we said x is negative 7. And if you look here, negative 7 plus 10 is a positive 3. Same answer. Okay, yay. All right, last question here. Now this one is substitution. They asked to do substitution, but nothing is solved for y, and nothing is solved for x. But if you notice that this guy, x, is almost alone, he could be alone if we just got rid of the 3y. So let's go ahead and do that. X plus 3y is equal to negative 13. We're going to minus 3y to both sides, minus 3y to both sides. Now, is negative 13 and 3y like terms? Well, no, they're not. So we can write them next to each other without having any problems. And now this problem was a little different than our other problems. We oftentimes solve for y, but x was alone here. So that just use that fact. X is negative 3y minus 13. X is negative 3y minus 13. X is going to be negative 3y minus 13. So 6x minus 9y is equal to 3, and x is equal to negative 3y minus 13. Okay, here we go. We only have one variable, y's, and we're going to bring those together once we combine our like terms. But let's go ahead and distribute our parentheses. Negative 18y, because 6 times 3, and then 6 times 13 is 6 times 10, and 6 times 3, 6 times 10 is 60, 6 times 3 is 18, 60 plus 18 is a negative 78, minus 9y is equal to 3. We have like terms here and here. Folks, are these y's on the same sides or on the different sides? They're on the same side, the left side. So we can combine these like terms to become negative 27y. I'm going to get rid of this 78 by adding 78 to both sides. So this is equal to 81. And if I divide both sides by negative 27, negative 27. How many times does, so the hint is, looking at this last number, how many times does 7 multiply to become a 1 at the end? 7 times 1 is 7. Nope. 7 times 2 is 14. That's not 4. 7 times 3 is 21. Oh, that might be it. And it turns out, yep, y is equal to negative 3, because 27 goes into 81 3 times. Now we solve for y, but we still have to solve for x. And the equation on top here, that's not solved for x. But isn't this one over here solved for x? That's solved for x. Let's go ahead and use this equation. X is equal to negative 3y minus 13. And we said y was negative 3. So x equals to 9 minus 13. X equals to negative 4. Negative 4. And that's our solution set. So if, when using substitution, one of the variables is not already isolated, just like our problems up here, see, y is alone. In this case, x is alone. We can solve for one of the variables by ourselves. Solve it for ourselves. And then we can then plug it in. Easy peasy. All right, thank you.